All right, so you should have already submitted this, your, I'm sorry, not this, but your, there we go. Sorry. Had to get myself set up here. You should have already submitted your Desmos graph that shows how to shift it. What did I say? Was it 5 units to the left? So if you played around with it, you would notice that you would have to, again, open up a set of parentheses. Inside of it, type in your x. But to shift it to the left, you must add 5, right? And why I say that's counterintuitive, right? Normally, when we think shifting to the right, as I did here, so think literally, guys, listen up here. This is important, right? It's all important, but this is seriously important, right? When we took the original parent, which is right here at the origin, vertex at the origin, and I wanted to shift it to the right, we actually had to use a -2 inside the parentheses. And I say that's counterintuitive, meaning your intuition is when it rains, you don't go outside, or you bring a raincoat, or you bring an umbrella, et cetera, right? That's your intuition. So my intuition in mathematics is if I had to move to the right, I would think it's addition, right? Correct? But it's not. It's actually minus inside the group, opposite of what your intuition is. Similarly, when we moved to the left, my intuition would say left of 0 is minus, like negatives, right? Every other time it seems like it. But in terms of graphing functions, it's opposite of your intuition. To move left, you open up a group and you add the amount of units you want to move to the left. In this case, it was 5 units, right? So x plus 5 inside the group moved not just the entire parabola, but specifically the vertex is really the key point to help us identify this. It moved at 5 units left, right? So that's the main point. So let's summarize what we have so far in our lesson. And I'm going to use the home feature. So what do we call the graph of y equals x squared? Yes, we call it a parabola, but we call it the parent parabola. I recommend that you copy this down into your notebooks, right? The graph of y equals x squared is called the parent parabola. To shift, and I would underline the word shift, a parabola up or down, we add or subtract after x squared. So for instance, while you're writing that down, I will show you x squared plus 2, right? We add +2 to move it up 2 units. And if I wanted to shift it down 2 units, I would use subtraction after the x squared part, all right? So -1, for instance. And there we go. So the colors here show the parent in black, the shift up in green, and the shift down in purple. And you can see the equations on the left are adding to move up and subtracting to move down. To shift horizontally, that means either left or right, opposite your intuition. That's the studying part. That's what we do across this country and across the globe as students. We study this, but guess what? Everyone does it. It's the same across the globe. You can look this up, but your first exposure to it is in this course. And if you take more math courses, as you shift graphs, it always behaves this way. That's the nice part, right? So if you were to go into a trigonometry course or beyond, when you need to shift other types of curves, and you want to move it left or right, it's going to be opposite of your intuition. But anyways, y equals, we're going to open up a group or set of parentheses. I like the word group, x, and I'll start by moving to the right. I use a minus. How about 6? Close my group and square, excuse me. And I'm just going to change the color because Desmos kind of cycle through its colors here. Again, I'm going to focus on the vertex as a point of reference. Here's the parent, and now we can clearly see it is 6 units to the right. Using subtraction inside the group, moved it 6 units to the right. Y equals, open up a group, x plus 17. I'll be quite a bit obnoxious. All right, and I'm going to have to go back to my home screen. I'll actually zoom out a little bit here. And again, I talked about yesterday about If we zoom out, how it changes perspective, but it allows me to see all the big picture. All right, I can still click on the vertex 0, 0. And by adding 17 inside the group, it shifted it to the left 17 units. So my goal to you in this video is your second task is, can you take a parabola and shift it 4 units to the right and 3 units down? So figure it out, play around with it, take a screenshot, screen capture, take a picture on your phone, put it in your Google Doc as your second picture. All right, I want 4 units to the right and 3 units down. Put multiple transformations together. I know you can do it. I haven't done it, but I'm going to leave that as your challenge for now. One more video to follow after this.